So this video is an introduction to the basic concepts behind polygon modeling in Maya. And there are two essential ways that you can model in Maya. One is to use polygon modeling, which is what we're talking about here, and the other is to use NURBS. And we're not going to touch on NURBS because they're more commonly used with architectural constructions and so forth, and not often used in a character production pipeline. So that's why we're going to concentrate on polygons, which is a relatively straightforward of modeling things in Maya. And what polygon modeling really is a way of creating objects by creating lots and lots of little points of light, or points in 3D space called vertices. Each one of these points here is a vertex, and we can join them up to create lots of vertices and to create polygon models or polygon topographies. 3D modeling is exactly the same, really, conceptually, as creating a sculpture in clay or plasticine. So if you've ever made a model using clay, really 3D modeling isn't so terribly different. You just in the same way that you create a clay model, so you create a model in Maya. The only difference is you can't actually touch the model in Maya, but it is just as real as the model in clay, and you can use that data to create a real physical model should you wish to. It gets done all the time on production. Polygons are basically composed of vertices, and the question arises, what is a polygon? And a polygon is simply a multi-sided object. Now typically when you're modeling in 3D, you use triangles, very common in games, or quadrangles, more common in Maya. Usually we're modeling in quadrangles, little squares, which modelers tend to abbreviate as quads. So you'll hear modelers talk about quads a lot. And what you don't want are multi-sided objects. If you have an object that, say, has 5 vertices, creating a 5-sided polygon, we call that an n-sided polygon, n for just a random number, and we tend to avoid those in Maya. So the trick with modeling is to use triangles and preferably polygons. And a good model, or a good surface topography of a model, tends to be composed of quadrangles or quads. Now, 3D models are composed of 3 basic components. There are your vertices. There's one vertex there, plural of vertex is vertices. So you can see here each one of these vertices makes up the boundaries of this cube. The second component is edges, and the edges are literally the edge of the cube, and then the face is the face of the cube. That's all relatively straightforward, and when we start modeling, you can basically manipulate both vertices, that is to say these little points in space, the edges created by joining them up, and the faces created by the edges and vertices. So you've got to remember vertices, edges, and faces. So what are vertices? Vertices are points in 3D space, and you can think of them as little sort of points of light connected up by edges, almost like little stars in the sky, if you like. And when you're thinking in terms of edges, you can think in terms of joining up those lights to create, say, star signs of the zodiac, the Great Bear or Cancer or whatever. And you can obviously join these vertices up to create polygons, a bit like joining up stars, or a bit like joining up stars to create astrological signs, as I've already said. Now the edges are the edges of these polygons that are created by joining up the vertices, and the faces are the faces of the polygons bordered by the edges. And you can select and edit all 3 of them in Maya. Maya will allow you to edit any one of these vertices, edges, or faces. And we can have a high-res or a low-res model. This is an example here of a very low-res model. It has, you can see there, it has very, very few faces, although they are all quadrangles. You can see that all of these faces are quads. And this is a low-res model. It has few faces, it has few edges, and it has few vertices. This one here is a medium-res model. You can see it's higher density. There are more polygons in there. And here, with this high-res model, you've got lots and lots and lots of polygons, so many that we'd have to go in very close to see the individual quads. This is more what you tend to be looking for with a surface topology, because it's going to give you a better and clearer result. However, low-res models are much lighter, and they use much less computing power, and so when you're animating, low-res models are definitely your friend. Medium-res, again, you've got better surface topography. It's easier to see. It's easier to create interesting characters and character expressions, but it is it starts to get heavier. And with the high-res topography, your models can get very, very heavy and cumbersome, and can be difficult to animate, although with the improvement in computing power in the last few years, that's less of a problem than it used to be. But still, the modeler's skill is really defined by using the fewest numbers of vertices to achieve the best possible result. And what modelers tend to look for is the fewest possible vertices to create the object. In other words, they tend to avoid complexity. Obviously, you need as much complexity as is required to make the model look good, but the trick with modeling is to use as few vertices as possible in order to get away with it. A few other important things to bear in mind now. You always want to begin your model at 0 on the grid. Very important to begin at 0. If you're slightly off 0, you can get into all kinds of trouble. And also when you're modeling, you tend to model half of the object. Typically we model, let's say we were modeling a chair, we would model half the chair and then duplicate it to create a mirror image of the chair, and then combine those into one model. That's your basic procedure, is you model on the grid at 0 half the object and then duplicate it to create the entire object. So those are the general principles of modeling. Now you should watch the technical video so that I can show you the interface and some of the main modeling tools.